Hello friends. In this review, we will talk about the Shelly Power Strip for Gen 4, a power strip with 4 sockets. Its main feature, in my opinion, is that it not only provides individual control of each socket, but in addition, each one has its own power consumption measurement. Not one shared sensor for the whole power strip, as in affordable alternatives, but separate monitoring for every connected device. That is exactly the main reason why I decided to take it for review. We will be taking it apart not only figuratively, but literally as well. We will do an external review, open the case, and look inside. Devices like this are usually placed under a desk, behind a cabinet, near equipment, and here not only the presence of smart functions matters, but also how neatly everything is physically made. We will go over the component base, without unnecessary pedantry, but with a proper understanding of the design, how the power section is laid out, where the control electronics are located, and what is actually hidden inside this compact case. Another noticeable feature of this model is the circular LED backlight around each socket. It can show the state of the output and makes the operation of the power strip more visual. At the same time, we will see how it works in Apple Home, whether there is separate control of each socket. And of course, we will check integration with Home Assistant. There is support for Wi-Fi, Bluetooth, Zigbee, and also Matter, so the device can be connected in different ways, both through Matter and directly through Zigbee, for example, in ZHA or Zigbee2MQTT. We will test all of this further in practice. And before we begin, as usual, support the video with a like and subscribe to the channel if the smart home topic interests you. Let us start with the device specifications. The Shelly Power Strip for Gen 4 is a power strip with 4 Type F European sockets. Each socket here has separate control and its own power monitoring sensor. Voltage, current power, and accumulated energy are measured. As for load, the total limit is 16 amps, or 3,680 watts for the entire power strip. At the same time, one socket is rated for a maximum of 12 amps, that is, up to 2,760 watts. As I already mentioned, there are several interfaces here at once: Wi-Fi, Bluetooth, and Zigbee, as well as support for Matter logic. The case is quite compact, 237 millimeters in length, 43 in width, and 56 in height. The power cable is 1.5 meters long. The box is made in the style familiar for Shelly. On the front, there is an image of the power strip itself, the model designation Power Strip for Gen 4, the body color, and the socket type, Type F. The main highlights are also immediately shown here: 4 smart sockets, individual consumption measurement, and configurable LED indication. On the side, the key specifications are listed: 230-volt power supply, maximum total load of 3,680 watts, up to 12 amps per socket, and up to 16 amps for the entire power strip. Here we also see the Wi-Fi, Bluetooth, Zigbee, and Matter markings. For Shelly Gen 4 devices, multi-protocol support is one of the main features. At the same time, it is important to distinguish. Wi-Fi and Zigbee are working connection interfaces. Matter is a logical compatibility protocol, and Bluetooth here is mainly used as an auxiliary interface for initial setup. The package contents are minimal, but everything necessary is in place. In the box, there is the power strip itself, a short paper manual, a separate card with the Matter code, and a sticker with QR codes for the Shelly app. The manual is quite compact, but it contains basic information on connection, safety, and device operating modes. The cable length is 1.5 meters. It is non-removable, so it will not extend the power line by much. But for simplicity of narration, I will continue to call the subject of this review a power strip. Individual socket control is possible here not only through the control system, but also manually. There is a separate button next to each socket. The included manual is made in the form of a large fold-out memo. There is a lot of text here because the information is duplicated in several languages, 12 in total. For everyday use, it is unlikely that you will need to read it in full, but it contains important things: electrical specifications, safety requirements, connection modes, and button combinations for switching between operating modes. I have highlighted the most useful points from the manual separately. By default, the power strip is configured through Matter over Wi-Fi. If you need to switch to Zigbee, hold the first button and quickly press the fourth button 5 times. After that, the device enters Zigbee network joining mode. The reverse transition from Zigbee to Wi-Fi or access point mode is performed by holding buttons 1 and 4 for 5 seconds. On the right, there is also a useful diagram. It shows how the sockets, light rings, and control buttons are numbered. We will return to these modes later, already in practice. In appearance, the Shelly Power Strip 4 looks neat. A white body. There is also a black version, rounded edges, and 4 Type F sockets in one row. Around each socket, there is a transparent ring. This is exactly what the multicolor LED indication works through. Also, there is a separate button near each socket. This is convenient because you can quickly turn a specific output on or off manually. On the back side, there are 2 stickers with technical information, model, load specifications, manufacturer data, and a QR code for connecting through Matter. There are also 2 mounting holes here, so the device can be fixed to a wall, behind a cabinet, or under a desk. For disassembly, I had to slightly damage the rubberized pad on the back side of the case, because the screws are hidden exactly under it. Moreover, the screws here are not ordinary ones, but with a triangular slot, so a suitable specialized screwdriver is needed for access inside. I should note right away, I disassembled the device only for the sake of the review and to look at the design inside. In normal operation, this should not be done. Under the top cover, you can see how the power cable is brought in. Phase and neutral go further inside the case, while the grounding is brought out to a separate brass bus bar. It runs along all the sockets and is soldered to the grounding contacts of each of them. Therefore, for further disassembly, this bus bar had to be unsoldered from the socket contacts. Here as well, inside the case, there is another sticker with the Matter QR code. It turns out that the code is duplicated in several places at once, on a separate card, on the underside of the case, and also inside the device. After the grounding bus bar was unsoldered from the contacts, it became possible to remove the second part of the case and reach the main board of the power strip. In this frame, it is shown from the reverse side. Here you can clearly see how the socket contact groups, the power input, and the brass grounding bus bar are arranged. There are no especially interesting components on this side. The main electronics are located on the other side of the board, and that is where we are going next. This is what the upper part of the case looks like. Holes for the control buttons are visible, as well as the plastic buttons themselves, which after disassembly are not fixed by anything and simply come out of their seats. There are no separate springs or complicated mechanism here. The buttons transfer the press to the micro switches located on the board. And here is the upper side of the main board. In the upper part, there are 4 micro switches. These are exactly what the buttons on the case press, and through them each socket can be controlled manually. The white rectangular elements near the contact groups are relays. There are 4 of them here, 1 for each socket, so the outputs are indeed controlled independently. Between the first and second, as well as between the third and fourth sockets, small chips are visible. They are responsible for power monitoring. On the right side of the board, a separate vertical control board is installed, and next to it, there is a switching power converter. Let us take a look at the relays. According to the markings, the relays themselves are rated for current up to 16 amps at 250 volts AC. At the same time, up to 12 amps per socket is specified for the power strip, so there is some margin in the relays relative to the operating limit. The relays are quite compact and are installed next to the socket contact groups. This arrangement allows independent control of each output to be preserved while still fitting the entire power section into a fairly small case. 2 AD7953 metering chips are responsible for power monitoring. Each AD7953 has 2 current measurement channels, so the device can calculate consumption separately for each socket, not just the total consumption of the whole unit. In practice, this gives 4 independent power values. You can see exactly which socket is loaded, build separate consumption graphs, track appliance switching events, and use this data in home assistant automations. In this part of the board, there is a switching power supply for the internal electronics. It generates 12 volts for the relays and 3.3 volts for the microcontroller. Here the main elements of this section are also visible: an inductor, several electrolytic capacitors, protective elements, and the control board itself, installed vertically relative to the main board. And this is the ESP Shelly C68F control module, installed on a separate vertical board. In the upper part, The printed antenna is clearly visible. It is the one that provides Wi-Fi, Zigbee, and Bluetooth operation, as well as the entire logical part, for which it has 8 megabytes of flash memory. Now let us move on to connection. We will start with the default mode, Matter over Wi-Fi. After power is applied, the power strip automatically enters pairing mode, and this is immediately visible from the indication. The rings around the sockets begin flashing blue. First, let us check connection through Apple Home. Since the device in the default mode works through Matter over Wi-Fi, it is added as a regular Matter accessory. We open the Home app, go to the Add menu, and select an accessory. After selecting Add Accessory, we scan the Matter QR code. The code was read normally from the sticker on the case, after which Apple Home detected the device as power socket. Next, Apple Home suggests choosing the room where the device will be located and assigning it a name. At this stage, you can leave the name as it is or immediately rename the device for your scenario. For example, Power Strip by the desk or Workstation Power. In addition, a separate name can be specified for each individual socket, which is logical since they are controlled separately and manage different devices. At this stage, the connection is completed and the device appears on the screen as a single tile. By default, all 4 sockets are displayed inside one tile. You need to tap it, and then a window opens with separate control of each socket. Their state is displayed simply as a quantity, switched on and switched off, but without a specific indication of which sockets are currently working. If that does not suit you, there is an option in the settings to display the sockets on different tiles. On the desktop, the state of each separate socket will be visible. This way it will be clearer what is currently on and what is off. By default, the socket numbering in Apple Home is mixed up. When sockets numbered 3 and 4 are turned on in the app, in reality 1 and 4 turn on. When switched on, the socket backlight glows green. Accordingly, 1 and 2 in the app are 2 and 3 on the power strip. However, this is not a problem because all sockets can easily be renamed. There are no other options in Apple Home besides on/off. Power monitoring is absent here due to the limitations of the system itself. For some reason, the creators consider this function unimportant. The sockets can also be used in automations, also quite primitive, but nothing else has been added here so far. In addition, the device can be added to other systems without removing it from Apple Home or removed from the system. For the sake of a clean experiment, I still decided to remove the subject of the review from Apple Home and reset it by holding buttons 1 and 4 until the sockets start flashing blue. After that, I proceed to add it to Home Assistant. For this, I need the app connected to my working server, where I go to the Settings section, the Matter item, add a new device. Next, everything is standard, as I have already shown repeatedly in my other videos. We allow camera access, scan the code. After that, the smartphone connects to the device through Bluetooth for initial pairing and transmission of the connection parameters. Next comes the final step, and the power strip is added to the system into the Matter integration. As the transport network, it still continues to use Wi-Fi, so no additional gateways are required. Unlike the minimal functionality of Apple Home, Home Assistant has just a huge number of entities. In addition to relay control, there are energy counters here, both consumed and exported. Although they have no practical use, it will be easier just to hide them. Each socket has its own separate sensor of power, current, and voltage, although voltage would have been enough to measure only at the input. The socket numbering by default here is completely correct. The first socket is considered the one closest to the power cable. Power monitoring works correctly and quickly. Current power, current, voltage, and consumed energy are displayed. I think the exported energy values are unnecessary and can be disabled. To assess the response speed of the power monitoring sensors, I decided to record a video. This is real-time mode. I did not speed it up. As you can see, everything is very fast, and unlike Zigbee, there is no risk of flooding the network. The data transmission channel over Wi-Fi is very wide. Now let us move on to checking operation through Zigbee. Let me remind you that for this you need to hold the first button and, while holding it, quickly press the fourth button 5 times. After that, the power strip enters pairing mode. What is very convenient is that here the backlight flashes not blue, but purple. First, Let us check compatibility with the standard Home Assistant integration for working with Zigbee devices, ZHA. The connection process is standard. The only thing that caught my eye was some unimaginable number of detected entities. Let us now look at everything in more detail. So let us begin. As expected, in a Zigbee network, the device acts as a router. As for control, besides the 4-socket relay switches, indicators of mains frequency were found here, and like voltage, only one copy can be left, the rest disabled. Apparent power in voltamperes, current, active power in watts. Next, power factor, amount of energy in kilowatt hours, and voltage. At the end, there was an identify button. When pressed, the socket backlight flashes yellow. As you can see, the set of entities here is indeed large. Here is an example of operation with a connected load. I connected a fairly powerful consumer, and the socket glows not green, but yellow, which is also very interesting and useful to understand the consumption level by color. All transmitted parameters look quite believable. Update interval, approximately within 10 seconds. When removed from the Zigbee coordinator, the power strip itself enters pairing mode. There is no need to reset it. In ZHA current at the time of testing version 2.12.0, it was detected correctly with the correct picture. External converters are not needed. Let us go over the entities that this integration method outputs. Control of each socket, and also, for each one, power values, voltage, mains frequency, current, amount of energy, also separate. Then the backlight behavior setting. Off, always off. Switch, switched off sockets glow red, switched on ones glow green. Power, default mode, switched off sockets do not glow, switched on ones are green. This, for example, is how the power strip will look in switch mode, with sockets 2 and 3 turned on and 1 and 4 turned off. Next come brightness settings for different backlight colors. I tested them, but I cannot say that there were any strongly visible changes when adjusting these sliders. Nevertheless, they are there. There is a mode to turn the backlight off at night, with brightness and operating time settings. There is an option to disable the buttons of each socket. Switch to detached mode, after which press the apply button in this block. I checked it, it works. Below is the setting for behavior after power restoration, also for each socket, and it works fine. And even lower there is an interesting block of Wi-Fi settings. On-off, network name and password, IP address, DHCP, gateway, subnet mask, and DNS. And a test power measurement. Here I connected 2 loads already, a small one, 16 watts. Here the socket glows green, and a powerful one, more than a kilowatt, yellow. The readings quite match expectations. The update time is also around 10 seconds. An expensive but functional power strip that has a whole range of interesting features which fully justify its cost. This includes support for several interfaces. You can connect it both through Zigbee and through Wi-Fi, and thanks to Matter support, easy integration into various smart home control systems. Separate control and power monitoring for each of the 4 sockets. I have not encountered that before yet. Visualization, in the form of backlighting for the sockets, both enabled and disabled ports, in Zigbee2MQTT. Different colors depending on load power. The ability to control the sockets manually and, if necessary, to disable these buttons programmatically. Overall, very positive impressions. From what I would like to add, several USB ports. I hope such a model will also appear. In my opinion, Shelly in this case really justifies its cost. That is all. I hope this video was useful and interesting for you. I will be grateful for your likes. They help promote this video on YouTube. If you do not want to miss new reviews and lessons, subscribe to my channel. In the description under the video, you will find a link to the store where you can buy this power strip, links to my social networks, Telegram channels, and a group for communication on smart home topics. Join. It will be interesting. Thank you for your attention. Until next time, peace to everyone.